Hello everyone, Bad Boy Calculus here. We're going to talk about conic section today. Conic section, there are 4 of them: circle, parabola, ellipse, and hyperbola. Let's start with circle. The standard equation of a circle is x minus h squared plus y minus k squared equals to r squared radius. The hk right here is your center. So hk, center. This r right here is your radius. In order to make a graph of this, you need to know where the center is, and then you're going to draw the radius. Let me give you an example real fast. So for example, you have an equation of 4x squared plus 4y squared minus 24x plus 32y minus 4 equals to 0. First thing you want to do is you want to move the number to the other side. You're going to group the x squared with the x, and then you're going to put the y squared with your y. Now, there are coefficients in front of the squares. You need to factor it. So we take out the 4, and we have x squared minus 6x. We're going to leave a little space in here. Plus, take out the 4, y squared plus 8y, leave a little space, equals to 4. The number you're going to add in here is simply the b number, which is the light blue right here, negative 6, divided by 2, and square it. And because of the square, you always have a positive number. 6 divided by 2 is 33 squared is 9. So you'll be adding a 9 over here. Plus 9. When you plus 9 over here, you're also going to plus 9 on the right side. Watch how the 9 has a 4 on the outside multiplying it. So you also need to multiply this by 4. Next, we're going to talk about this number. This number divided by 2. And square that. That will give you a 4 squared 16. You add 16. When you add 16, you also need to add 16. Look at how the 16 is being multiplied by 4 again. So you also multiply this one by 4. Now we're going to simplify this math right here. 4 x squared minus 6x plus 9 plus 4 y squared plus 8y plus 16 equals to, this number right here is going to be a 64. Actually, it's 104. 104. Okay, so now, once this is done, you want to divide everything by 4 because for a circle, you can't have any of these coefficients. And you realize the coefficients are the same. So we're going to divide that. But before so, let us condense these factors. So this is going to be x minus 3 squared. How do we get that? Well, you just square with the front and we do half of whatever that's in front of x. And you'll be able to complete the square to this one. Plus the 4. 4. This is going to be y plus 4. Again, square root of this one, half of the front number, you'll be able to get 4. So, you have parentheses square equals to 104. Now you divide everyone by 4, which will give you x minus 3 squared plus y plus 4 squared equals to 104 divided by 4, which is 26. Here is a standard form of a circle. You will have your vertex hk, not your vertex, your center hk as 3, negative 4. 3 from here, negative 4 from here. They're opposite of what's in the parentheses. So that means if you have x minus 3, you just have a positive 3. Y plus 4 is a negative 4. This guy is your radius, square. So your radius is simply square root of 26. I'll say this is around 5. So when you graph it, you will simply go to 3, negative 4. So 3, negative 4. And you're going to go a radius of around 5. So you're going to go up 5. Square root 26, go right, left, and down. And after you do so, draw a circle around it, and that's how you do a circle question. Now, keep in mind that the circle has an eccentricity of a 0. Eccentricity is basically measuring how elliptical your thing is. Well, a circle is perfectly round, so there will be no eccentricity for that. So this is circle. Let's go on to the next one, which is parabola. So a parabola has 2 different shapes. One is a happy face, sad face, up and down. And the other one is a right side, open right C shape, and the left side. The equation of the up and down is y equals to a x minus h squared plus k. Look at the squares on the x, where the y has no square. The bottom two are x equals to a y minus k squared plus h. Notice how the square is on the y and the x has no power. The h and k will be with their x and y. So if this is a h, it's going to be with the x. And whereas if this is a y inside, you're going to have a k inside as well. So for these two graphs, they all have what we call a vertex. So vertex is the red dot right here. It is the lowest point, highest point, rightmost point, and leftmost point. Those vertex are called HK. These are all HK right here. No matter which way it points to, it is going to be H first and K next. Inside the mouth, this is like a happy face of the mouth, you get a focus right here. So focus is going to be inside. So these are where the focus are. And the distance from V to F, right here is called P. So here's P, here's a negative P because you have to go down to find the focus. This is another P. This is going to be opposite of P, negative P again. And lastly, go on the opposite side of what P is, you get a directrix. Directrix is simply a line that is dotted and is not going to go through your graph. So go opposite. The vertical one will have y equals to, where the horizontal one will have x equals to. Now, as in, what are these numbers? Just imagine this point right here is, this green one right here is below the k. So this will be k minus p. This will be k plus p because it's above it. This one will be x equals to h minus p. And this one will be x equals to h plus p. I'll show you an example on how this works. So for example, if you have y squared plus 8y minus 4x plus 8 equals to 0. The first thing you notice is this is going to be a parabola because you have a square on the y, but there is no square on the x term. And so if you have only one square, but the other variable doesn't have a square, it's going to be a parabola. You want to do is you want to move the number and the variable that don't have a square to the other side. So I'm going to add these two over first. You have y squared plus 8y equals to 4x minus 8. And you will do completing the square on the left side. You got y squared plus 8y. You take this number, divide by 2, 4, square that, 16. You can add 16 on both sides. And once you did that, this, again, you're going to condense it to y plus 4 squared. And here you have 4x plus 8. You can minus the 8 over. Minus the 8 over. And you're going to divide by 4. So when you divide by 4, you get x equals to 1/4. Y plus 4 squared minus 2. Here's one thing I want to point out to you is that at this step right here, if you simply take out the 4, you have y plus 4 squared equals to 4 times x plus 2. This is what we call a standard form in a parabola in conic section. So sometimes your teacher will want standard form and you want to do that. So a standard form is simply a complete square like this. A square equals to whatever you need to factor, you factor on the right side. All right, well, in this case, we don't need a standard form. We just want to know how this graph looks like. So here's my equation, x equals to 1/4 y plus 4 quantity square minus 2. Let's get our HK real fast. H is going to be the number on the outside right here, yellow. K is going to be the number that's inside with the y. And since it's inside, it's going to be opposite, so it's -4. We got a vertex at -2, -4. A is going to be the number multiplied in the front of the parentheses. So it's this little 1/4 right here. We'll quickly find P first. How do I find P? P is 1/4A. And obviously, A is also 1/4P. So you can use whichever one that you need to use. In this case, I want to find P. So, and I have A. So I'll put the A back in here. You get 1/4 times 1/4, which is 1. All right, we're going to make a quick graph real fast. So -2, -4 is my vertex. So I'm going to go to -2, go to -4, and here's my vertex. P is going to be 1. Now, what's the direction of this? Well, it's x equals to y squared, and it's a positive front, so it's going to be a sideways point to the right side. Point to the right side. Now, vertex is right here. The P is 1 means that you're going to go 1, and you'll find your focus. Here's the distance of 1. Here's your vertex right here. Let's put it in yellow. Vertex. So your graph is going to move to the right side, opening like this. Now, where's your directrix? Your directions will be right opposite, same distance, which is 1, to the left. Draw a dotted line. You can see it's a vertical line. So the first thing I write is that the directrix is x equals to, well, this point is a -2. You move that way 1, so it's -3. Where's my focus? Well, my focus is going to be your original point of the vertex is -2, -4. And you move to the left one, so you move to the right one, so you +1 on the x value, which is going to be -1, -4. If you have a nice graph, you can kind of see it already. But if you don't, you simply add or subtract on the x value, h, because they're on the left side and the right side of the vertex. The next one I want to talk about is going to be an ellipse. So for ellipse, the equation is x minus h squared over a squared plus y minus k squared over b squared equals to 1. There's another form that is y minus, you have x minus h squared over b squared plus y minus k squared over a squared equals to 1. There's a plus in the middle, so it doesn't really matter which one comes first. The only thing that you have to know is, number 1, a must be bigger than b for ellipse. And number 2, c squared is equals to a squared minus b squared. Notice how it's opposite to the formula. This is a plus, and so this is a minus sign. Your teacher might give you a different form, different looking form, but essentially it's the same thing. This is easier to memorize. Because a is always bigger than b, as we mentioned, so this is going to be a bigger bottom. This is going to be a bigger bottom. Whoever that has a bigger bottom is going to be a dominant side. So for the top one, since x is on top of the a square, x is longer. So you can think of it as a longer horizontal, shorter vertical ellipse. Looks like that. And for the second equation, because the big number, a squared is under y. So vertical y is longer than the x. So you can think of it as an ellipse, but it's vertical like this. Okay. Each ellipse is going to have a couple things you want to know. So I'm going to use the first one as an example. You're going to first have a center, which is the middle. And say your long side is horizontal. You're going to go A, left and right. And then you're going to have B to go up and down. And it's going to be shorter. B is always shorter than A in that ellipse. I'm going to draw the curve like this. On the end of the long side, these two yellow points are called vertices. It's the same as vertex, it's just a plural form for that. Vertices V. On the long side is V. On the short side, these two, oh, this is too dark. On the short side, these two are called co-vertices. Some people also call it vertices on the minor axis because the short side is called minor axis. So this whole length right here is called minor axis. The length of that, this whole long thing right here is called a major axis. So the major axis is simply 2A. And the minor axis is 2B. Last thing I want to talk about is the focus. There are two of them, so we call it foci. Some people will pronounce it as foci, foci. Foci is the more correct way to pronounce it, I would think. So your foci is on the long side, usually a little closer to the end than to the middle. So the distance between the center to the foci is called C. All right, so let's go ahead and do an example and see how this works. So for example, we have an equation of 4x squared plus 36y minus 32x plus 9y squared plus 64 equals to 0. So we'll have a x squared group up with the x. We'll have the y squared group up with the y. And we'll have the number thrown to the other side. Again, before I do this question, I already know this is a ellipse because the x squared and the y squared, they're both positive and they're different number. If the numbers of the x squared and the y squared, which what I'm talking about is the 4 and the 9 here, if they are the same number, then you're probably going to have a circle. If they are both positive, or maybe they're both negative, then you have an ellipse, which is in this case. Why I said probably instead of for sure, because there is a thing called degenerated conics, and that is like a special case for a conic section, but we don't usually really talk about it. Next, we're going to factor out the coefficient of the square. So we will have this for the x's. We're going to leave a little space right here because we need to do complete the square. And we're also going to take out the 9 for the y square, negative 64. Let's figure out what to add in here again. The number we add is going to be the number negative 8 divided by 2, which is 4, square that, 16. You're going to add 16. When you add 16, you add 16 to the right side times 4, because there's a 4 multiplying on the outside. On the y term, you're going to be adding 4 divided by 2, which is 2 squared is 4. So add 4. Again, you'll be adding 4 times 9, the coefficient in the front. Right, we're going to copy the 4 and then we'll condense this quadratic into x minus 4 squared plus 9 y plus 2 squared equals to, the right side is going to end up to be 36. We're going to divide everyone by 36 because the right side has to be 1. So we have x minus 4 squared over 4, and 36 will simplify to a 9 on the bottom. And 9 and 36 is simplified to 4 on the bottom. And this is a 1. That is what we call a standard form of a ellipse. Now, we're going to identify what is A and what is B. The bigger number is your A squared. 9 is bigger. So A squared is equals to 9, which means A is equals to 3. The smaller number is b squared, so b squared equals to 4, so b is equals to 2. Let us quickly find what c is equals to. So c squared is, again, a squared minus b squared. So if I just do 9 minus 4, it will be 5. So c will be square root of 5. The next point is HK. HK is probably the most important point here. You gotta make sure it's correct, otherwise everything else will be wrong. So HK is going to be inside the x and inside the y. You're going to go opposite. So negative 4 will be 4, and the plus 2 will give you negative 2. Now, once again, the 9, which is the bigger number, is under the x. So that means x is going to be longer. So we're going to go to a 4, negative 2. I'm not going to draw the coordinate here because sometimes it's confusing. So I'm just going to go to the middle of the graph and just put 4, negative 2. Now, the x direction has an a of 3. So you're going to go to the left 3 and right 3. And we're going to draw a vertex. So this is the left side. This is the left side and the right side. So a equals to 3, a equals to 3. You're going to have 2 endpoints right here. We call it the vertices. So where are the vertices? Well, it's simply just going to be 4 minus 3, negative 2, and 4 plus 3, negative 2. If you do simplify, that's 1, negative 2 on the left end. And you're going to have 7, negative 2 on the right end. That's your A. Now the B is going to be 2, so we're going to go up 2 and go right 2. So go up 2. So when you go up 2, this point is going to be 4 co-vertices. So your co-vertices is just going to be 4, negative 2 plus 2, and also 4, negative 2 minus 2. On the other side, you're going to build down 4 to here, co-vertices. Let's write down these points. So these are 4, 0 on the top, and 4, negative 4 for the bottom. Right, so now we kind of know how the graph looks like. So the graph of this ellipse is going to look like this. It's a horizontal ellipse. The major axis, again, is the length of the ellipse. So the major axis is the entire thing right here. We know the A is 3, so that means the major axis, big MA, is 6. And now the minor axis is going to be the width of this ellipse, which is the green line right here. It's just going to be small ma equals to 2 times of the b. B was 2. Let me put it back on here. So it's 4. Last thing I want to talk about is your foci. So where are your foci? And don't forget, the foci is going to be C away from the center. We got it right here on top that C is equals to root 5. So that means on the long side, you go left and right, root 5. You'll be able to get your foci, 2 of them. Since it's left and right, your foci is just going to be starting from the center, 4 plus and minus root 5. Your y value stays the same. Again, we're going to talk about eccentricity before we move on to the last one. Eccentricity is C over A. C is the value of the root 5. And A is just your longer axis, so it's going to be 3. And that is your eccentricity of that. So this is how you do a ellipse, how you draw an ellipse and find everything that you need to know for an ellipse. Last one of the conic section, we're going to talk about hyperbola. So how does a hyperbola look like? Well, there are again two equations. One is going to be x minus h squared over a squared minus y minus k squared over b squared equals to 1. This is what we call horizontal hyperbola. The next one we have is going to be a y minus k squared over a squared minus x minus x squared over b squared equals to 1. A vertical hyperbola. There's a minus in the middle in the formula, so which means that the x and y cannot simply switch around however they want. We're going to have to make sure the positive stay on the top, in the front, and the minus stay at the back. Okay, so make sure that happens first. All right, so we talk about in ellipses, a has to be bigger, right? In a hyperbola is not. A could be smaller, a could be bigger, a could be equals to b. It doesn't matter, but I want a to be in the front, which means a is with the positive guy and b is at the back. You can just remember b for back. Okay, so whatever number you see in the front is your a squared. And then on the back is going to be b squared. The second one is your focal formula. C squared equals to a squared plus b squared. Again, notice how it's opposite. The formula has a minus. That's why this equation has a plus. Okay, it's kind of opposite. Again, there's another way you can write this, but essentially it's the same equation. You just move the variables around. So now how does the graph looks like? Let me show you this as an example of how the graph looks like. The graph is pretty big, so I'm going to move on to the next page so you can see more clear. If I have a x minus a squared over a squared, so a squared is in the front minus b squared is always at the back equals to 1. First of all, if your x is in the front, it's simply going to be a horizontal hyperbola. A horizontal hyperbola looks like this. It looks like an x, but it's like two parabola horizontal to each other. If it was a vertical one, it would simply be up and down. Now, the next thing you want to do is you want to look for the center. So again, the center is going to be right here within the x and y. So center is HK. Let me draw the picture real fast. Here's the center, HK. And now the a is under the x value. As you can see, the a is under the x value, which means on the x direction, you're going to go a. Now, I don't know how long a is in this case, so we're just going to draw an a arrow to left and right. Left and right because it's under the x. The b value is under the y, so which means you're going to go up and down b value. Now, again, b could be longer, could be shorter, could be equal. So since we don't know what number it is, we're just going to draw b like this. Next thing you're going to do is you're going to draw a box around it. So a box will be the length and the width of this entire a and b's. So here's your box. And after you draw the box, you connect what we call the diagonal. Now the diagonal is a very, very important thing in here. We need to find it. So let's use yellow for that. Here is connecting diagonal with the center. It will pass through the center. So if you don't pass through the center, you know you did something wrong probably. So it passes through the center, goes from corner to corner. These are your what we call asymptote. We have two of them, asymptote number 1 and asymptote number 2. We need to find those as well. But let's finish our graph first. Again, we talk about this as x in the front, so it's going to be a horizontal hyperbola. You go horizontally to from here, which is where the a points to, and it's just going to draw a graph that approaches, which means getting closer and closer to your horizontal, not horizontal, your asymptote, but don't touch it. So here's how my graph looks like. Last thing, of course, we have the focus. The focus is always going to be inside the curve, which in this case will be right here, the light blue, and also going to be right here, the two foci. Again, the distance from your center to your foci is called C. So right here, that distance right here is called C. There's going to be two of them. One is to the left, one is to the right. So this is how the graph looks like for a horizontal one. Now I'm going to show you an example of how an equation of a hyperbola would look like, and then we can show you how to find all the stuff that you need. And because I show you a horizontal one, this example is going to be a vertical one, so you can see the difference. All right, let's start with an equation of 9y squared minus 4x squared minus 18y plus 24x minus 63 equals 0. As usual, you want your square 9y squared and the y to be together, so I'm put these two together first. You want your 4x squared and your 24x together, 63 on the other side. We're going to factor the coefficient. Leave a little space. Factor the negative 4. Watch out, this is a negative 4. So the plus 24 is going to become a minus 6 now. Leave a little space, equals to 63. Think about what number you will need to add here. This number you add is plus 1. Since you plus 1, this one is going to be plus 1 times 9. And now the next part is going to be this one. This number is going to be a plus 9. So you're also going to be plusing a 9. However, this plus 9 has a minus 4 on the outside. So you're minus 4. Right, so what we have is going to be a 9y minus 1 square minus 4 x minus 3 square equals to, that's a 36. Again, we divide everything by 36. We have y minus 1 square. 9 divided by 36 on the bottom is 4 minus x minus 3 square over 9 equals to 1. Now again, this is a hyperbola because there's a square in between the x square. There's a minus between the x square and the y square. The front number will be your a square. It doesn't need to be bigger. In this case, it is smaller, which is fine. A squared is equals to 4. A is equals to 2. The back number right here is your b. B squared equals to 9. B is equals to 3. We're just going to get the c squared real fast for our foci. So c squared is equals to a squared plus b squared, which is 4 plus 9, 13. We took a square root, so c is equals to root 13. All right, we're going to go to the graph, and then we're going to find a lot of other things for this hyperbola. First of all, our center, probably the most important thing in here. The center HK is always with the x and y. And again, the x is at the back, so it's going to be 3. The y value is y minus 1, so the k value is 1. 3, 1. And again, because we don't want a very confusing graph, so we don't want to use the coordinate, we're just going to start from the middle of the graph and say this is 3, 1. A is 2. So you're going to go 2 on the y direction because y is in front with the a square. So you're going to go up and down 2. So up 2, down 2. Gonna have 2 points right here when you go up and down 2. And notice how I labeled the 2 right here because I might need to use it later. So that's 2. Now the b value is 3, which is under the x, so you're gonna go horizontal 3 and 3. So 3 on the right and 3 on the left. Here, the 2 points. So now we're gonna draw a box around it. So the box will be right here, the white one. It's an imaginary box, so just draw a dotted line. Okay, I drew my box right here. So next thing, I will connect the diagonal, and it has to pass through the center. So let's draw it this way. It will pass through the center. And then we'll draw it this way. We'll pass through the center. And this is your asymptote number 1. And this is your asymptote number 2. We will find them later too. The next thing we want to do is we will determine which way does this go. You have a y square in the front, so the graph is going to go vertical, the y direction. So you're just going to go vertically, starting from right here, the red dot. Go towards your asymptote. You have 1 on top, and you have 1 on the bottom. That's your vertical directed hyperbola. My foci is going to be inside the curve, so it's going to be right over here and right down here. And again, the distance of center to the foci is your c value, which in this case is square root of 13. I'm going to write it down as well. So let's get all these things first. First of all, vertices. What are vertices? These red dot right here, because these are where your graph starts. So your vertices is simply going to be, again, if you look at the graph, it's from your HK 3, 1, going up and going down 2, so plus or minus 2. Well, if you simplify this number, it's simply going to be 3, 3 for the top one, and 3, negative 1 for the bottom one. Those are your vertices. Now, the green ones, you don't really need to worry about it because it doesn't really go to anything. It's empty. However, you might want to know that this length of this box right here, which is from the middle of nowhere to another middle of nowhere, this is called conjugate axis. Conjugate in English sometimes means like you make it up. Yeah, because there's nothing really there, so we just call it conjugate axis. Whereas from the red dot to the red dot, which is like the width of this rectangle right here, we call it transverse axis. Transverse, you can think of it as like transferring is like from this point to this point. There's actually 2 points on there, so transverse axis. So if they want to know how long it is, in this case, for example, the transverse axis will be 4 because there's 2 2's right there, and then the light green one, which is the conjugate axis, is just going to be 6. Again, it doesn't really matter which one is longer. They could also be equal to each other, which will have a box like a square. All right, so the next thing we want to find is, let's find the foci. You can see the foci is above and below, again, the center. So we'll go to the center, 3, 1, and just going to plus or minus your C value, radical 13. Well, radical 13 is an irrational number, so most of the time we're just going to leave it. We don't really need to simplify. But if your teacher wants you to write as 2 separate ones, you can just go ahead and write 2 separate ones like that. All right. Last one I want to talk about is your asymptote. There are going to be 2 of them. Now, the reason why I want to write down all the values earlier, like the 2 right here and the 3 right here, because we want to use it now. Now, your asymptote will pass through the center. And if you have learned line equation, you will know any line equation could be written as y minus y1 equals to mx minus x1. And I did mention that you will pass through the center. So you're going to replace your x1 and y1 by your center, which means your x1 becomes h and your y1 become k. So let's write down an equation. It's just going to be y minus k equals to slope x minus your h. Now, what is the m? There are going to be 2 of them because there are 2 lines, right? So all you need to do is just look at this. Let's look at asymptote number 1. It has an up arrow of a 2 right here from the center, this red one. And it has a run arrow of the right side of a 3 right here. So your slope is simply going to be rise over run, 2 over 3. Now, asymptote 2, you don't need to do anything. It's just going to be opposite. They're guaranteed to be the same number, but one is positive, one is negative. Again, 2 over 3 because the up arrow in this case is 2. The run arrow, which is the horizontal one, is 3. So 2 over 3, 1 plus, 1 minus for those 2. So now we're going to go back to our equation right here. So what is my asymptote number 1, you'd say? Well, you will first have y equals to your k value. Your center was, let me see, 3, 1. Your center, again, is on top right here, 3, 1. So y minus 1 equals to 2/3 x minus 3. That's it. Now, some teacher want you to solve for y. So if you want to solve for y, you can go ahead and just do simply distribution plus 1. So there you have it. You have your first horizontal first asymptote. Want to find asymptote number 2? All you got to do is change your slope from 2/3 to negative 2/3. Now, that doesn't mean you can just make this a negative and call it a day. It doesn't work like that. You have to redo the whole process because the number will be different. We'll put negative 2/3 this time. The hk will be the same as the top one. And again, if you want to solve for y, you simply is just going to do the distribution and add the 1 over. Again, notice the y-intercept is going to be different, so don't be lazy and just put the plus or minus in the front. You actually have to solve for the whole thing if you want to. So here's your asymptote 1 and asymptote 2. Last thing to talk about for a hyperbola is eccentricity. The eccentricity is always going to be c over a. And c is going to be, in my case, let's see, the c is right here for light blue, square root of 13. So square root of 13. A value still going to be the a value, which is 2, so 2. And notice this number is bigger than 1 because in general, hyperbola will have an eccentricity of bigger than 1. Let me make a list for you to see. We have circle, eccentricity is 0. We have ellipse, eccentricity is between 1 and 0. Eccentricity is always positive, so there's no negative number. Parabola, eccentricity by definition is equals to 1. And then you also have hyperbola, where your eccentricity is greater than 1. And that's basically it for pre-calculus level conic sections. If you have any question, leave a question in the comment. And if you like the videos, make sure you subscribe and like, so I will drop the next video and you will be able to watch it right away. Thank you for watching, and I'll see you in the next video.